So, hello students, how are you? I hope you are doing good. So, a very good evening to all of you. Firstly, make sure my screen is visible to you and I'm audible to you. If yes, this please write it in the chat box. Okay. So, please reply in the chat box if the screen is visible to you and I'm audible to you. JNV Bhavnagar, Gautam, so that we can start the lecture. Okay. Okay, Gautam, thank you so much. So here we are with our question discussion lecture series on work energy and power. Okay, in the previous session we have did numericals on laws of motion, and that was the last session on laws of motion. Now we are starting the new session with work energy and power, and here we are with our question discussion part number one. Okay, so let's just wait 1 or 2 minutes more. Let the others to be done join. Okay, so good evening, Jhansi Rani. I hope you have attended the weekend classes or weekdays classes, na? Yeah, I remember you. And JNV Bhavnagar also. Gautam is also here. So we are going to start our lecture on question discussion on work energy and power. Good evening. So, yeah. Firstly, I am discussing some important concept and formula to solve these questions that I am discussing today. Okay. So that you will have some idea that how to solve that, how to proceed in that kind of question. Okay. So that we are going to deal with. Got it? Now, the very first topic that we are going to study here is the dot product and work done. Although these topics you have covered in your previous session, I think. Okay. So dot product, it is the scalar product, first of all. We have two kinds of product with vectors. So first is the vector product or cross product, and second is the dot product. So we are interested in dot product. So we will see only the dot product over here. Now what is that? It is if A vector is here, dot product with B vector, then this has a magnitude of AB cos of theta, which means magnitude of A multiply with magnitude of B multiply with the angle of the cosine of the angle between them, which means if this is the vector A and this is the vector B, then and this is the angle between them. So A dot B means A vector dot B vector equals to AB cos of theta. Okay. You can also uh, expand it to further, like this is your vector B and this is your vector A. This is the angle theta. So if you resolve this vector A in the direction of vector B and perpendicular to it, then you will have two component. Okay, it is A sine theta, and it is this component is A cos theta. So you can write it as also this dot product also you can write as A vector dot B vector is equals to the component of A, component of A vector in direction of vector B multiply with magnitude of vector B. You can say it easily. You can write it as B into A cos of theta. This A cos theta is nothing but the component of vector A in the direction of vector B. Or you can also write it as A times B cos of theta. This means you have to resolve vector B in the direction of vector A. So this is the component of vector A and vector B in the direction of vector B. This is B cos theta. So these many ways are here to write the dot product between two vectors. Got it. Now what is the how to calculate angle between them? It helps us to calculate the angle between two vectors. Okay. So angle between two vectors is equals to, you can say here that A dot B is equals to AB cos of theta. So cos of theta is equals to A dot B divided by AB, and theta here you can say cos inverse dot product of both vector divided by their product of magnitude. Okay. So this is the angle between two vectors. Noted. We have three unit vectors, three unit vector. कौन से? This is x-axis, y-axis, and z-axis. So in the direction of x-axis, we have a unit vector which representing the x direction, which is nothing but I cap. The direction vector of y-axis is j cap, and the direction vector of z-axis is k cap. Now you can see here that I dot I, if you take the dot product of I vector with I, you have to say that magnitude of I cap multiply with magnitude of I cap AB cos of theta. The angle between them. What is the angle between I cap and I cap? So it is 0 degree. So cos 0 is 0, which means cos 0 is 1, and magnitude of unit vectors are 1. Magnitude of I cap is 1, magnitude of j cap is 1, and magnitude of k cap is also 1. Okay. So it is 1 into 1 into 1, which means similarly I cap dot j cap results in magnitude of I cap, magnitude of j cap multiply with cos theta, the angle between them. And you can clearly see here the angle between I cap and j cap is 90 degree. So cos 90, which becomes 0. Okay. So from these two relation, you can conclude that j cap is equals to 1, k cap dot k cap is equals to 1, J cap similar unit vector multiply the dot product between similar unit vector gives you 1. Otherwise 0. For unit vectors also. I cap dot j cap is equals to 0. J cap dot k cap is equals to 0. And k cap dot I cap is equals to 0. You can learn this from this cycle. This is I cap, j cap, and k cap. So I to j, which means I dot j is 0, j dot k is 0, and k dot I is also 0. Got it? Now, this is the all information about the dot product. Okay. Now we will see the work done formula. What is work done? So work done by a constant force. So according to the definition of work done, it is said that work done is nothing but dot product of force vector with displacement vector. So it is the dot product of force vector with displacement vector. It is a scalar quantity. It is a scalar quantity, which means you do not need to worry about the direction. Okay. And its unit is what? The unit of work is joule. Okay. Now, this is the formula for work done. We can modify this formula. We can write it as magnitude of F, magnitude of D into cos theta. This is the formula for scalar product. F dot D is equals to FD cos of theta. You can take D cos theta, which means if displacement is here and force is acting in this direction, okay, force is acting in this direction. So what you can do, you can resolve this displacement in the direction of force vector and multiply it with the magnitude of force. F into D, which means F into component of D in direction of F vector. Yeah, you can simply write it as, just a second. You can write it as df, which means component of d in the direction of force vector. Because if the component is along x-axis, you can write it as vx now. So here the component is along f, so you can write it as df. We can. Another modification, you can say that it is f cos theta into d. So it is nothing but f in the direction of d, the component of force in direction of displacement, multiply with displacement ka magnitude. So these formula you can take in your hand. Okay. Now, unit is also joule. It is a scalar quantity. No need to worry about the direction. Now, one thing more, when we are discussing work done, so work can be done by two forces. The first one that I have taken here is constant. But what if the work is done by a variable force, then what would happen? So we will see work done by a variable force. Variable force. Now we will consider the variation of force with distance x, and suppose the force is varying in this manner. Okay, so this is the variable force, because at every instant of this, every instant of, yeah, at every position, each and every position on x-axis, it's changing its magnitude, you know, it's changing its magnitude. So this is a variable force. It is a variable force. Now, what we will do, we will consider a very small section of distance, which is dx. We will consider a strip here, which lengths in dx. This is the strip, or let me just change the color out. Okay, make sure the color is visible to you. I think this color is visible to you. Visible to you, everyone, na? Okay. So we have taken a strip, very small strip of length dx. Okay. So this has a length dx. Now, if the force is variable, and you will see this strip, although I have made it a little lengthier, but it is very, very, very small. So for that interval, if this is the curve, let's say f is varying as x square, okay, which means at x is equals to 0, the force is 0. At x is equals to 1, force is 1. At x is equals to 2, force is 4, 2 square 4 Newton. But what if, what if I measure the magnitude of force from x is equals to 1 to x is equals to 1.00001. Now this delta x, this difference is very small, which means 0.0001 is the value of x that you are going to put, because this is the value that had been changed, because the particle or the object has moved from x is equals to 1 to x is equals to 1.00001. Okay. Now, if you put this value in the expression of force, so what will happen? Or if you would calculate the value of force at x is equals to 1.0001, which means 1.0001 square. So it is nearly equals to 1, because 0.0001 plays no role, and it square also, which means it will become 0.008 times 0 and 1, which is very small. Okay, just a second. There is some technical glitch can take over. Is this visible to you now? The black screen is visible to you? Sorry for the technical glitch that has been happened. Okay, okay, Jasi. So what I'm discussing is that f is equals to x square is the variable force that I have taken. Okay. And I have put the value x is equals to uh, at x is equals to 1 the force is 1 Newton. Lekin what if I put x is equals to 1.000001, which means I have displaced with a very small value, with a very small value. For that, the force will nearly equals to 1 Newton if you put this value in x square, because these zero are going to double, which means it reduces the value of 1, this expression, and it nearly comes about 1. Okay. Which means for very small displacement, for very, which means the infinitesimal, infinitesimal, it's a very small displacement, displacement, the variable force behaves as the constant force. You have seen here, for x is equals to 1, it is 1 Newton. And for x is equals to 1.000001, it is nearly about 1 Newton, which means the force is not changing its value for very infinitesimal displacements. Okay, so we can consider an infinitesimal length and apply the force on it, and for that strip the force will behave as the constant one, and then we will calculate the work done by moving so, and then we integrate it. Okay. So this is the force which is varying with respect to x. We have considered a small strip into that. Okay, having length dx. Okay, and the force is displaced from, sorry, the object is displaced from here to here at x-axis. So work done here is, because the distance, or sorry, the displacement is very small, so the work done will also be very small, which means here the work done is also very small, which is dw. It is nothing but f dot dx, and if you integrate it, then you will have the total work done. Okay, and these are the limits, limit of x from, let's say, x1. The object has been moved from x1 to x2, so limit will be x1 to x2. Okay, got it? Now if you will see here that this is the variation of f with x. Okay, this integration of f dot dx is nothing but, this integration f dot dx, only this f dot dx is nothing but area of this strip, area of this strip. Why? Because this strip act as a rectangular strip. This value is f, height on the vertical axis, and this value is the displacement, which is dx. So area of this strip, area is equals to f dot dx, which means length into height. Okay, इसका मतलब क्या है कि these graph are made up of, we can consider infinite number of strips, and if we add them, then we will have the total area of this curve, under this curve. Okay, so what we are doing in work done, we are just adding those strips, we are adding those areas, because f dot dx is the area of that one strip. And what we are doing? We are adding the strip which is coming between x1 to x2. Okay? x1 to x2, and this is the variation of x. So we are adding those strips, which means we are calculating the area under f of x curve. Okay? So work done here is nothing but work done is equals to the area under fx curve. Got it? Okay. So these information that I have to convey to you. Now we will head on to the questions and see them one by one. Now, this is the very first question on your screen. Now try to solve it. I have talk about the formula that how to calculate the angle between vectors. Okay. So try to solve it. I'm giving you one minute. Okay. The magnitude of two vectors are 2 and 3, and the magnitude of scalar product is 2 root 3, then what is the angle between the vectors? It's a very simple question. Huh? Try to solve it. Jhansi, try to solve it. You are here. Yeah. All of you are present in this lecture. Try to solve this question. Okay. Now, we know the formula of dot product, which is A vector dot B vector is equals to the magnitude of A, magnitude of B into cos theta. And the angle between the vector is cos theta is equals to dot product of A vector dot B vector is equals to divided by magnitude of A, magnitude of B. Okay. Now, in this question, the magnitude of two vectors are already given, 2 and 3, and the magnitude of their scalar product is also given, which is 2 root 3. Okay, which means here A dot B is given to us as 2 root 3, and magnitude of vector A is given by 2. Let me consider the first vector is A, and magnitude of vector B is given as 3. Now, cos theta is equals to A dot B by magnitude of A and magnitude of B. Now, what is A dot B? It is 2 root 3. Let me just check. Huh? Jhansi, 2 root 3. Magnitude of A is 2 and magnitude of B is 3. 2 by, cancel 2, and this will become root 3 will cancel this 3 root 3 times, because 3 here is root 3 into root 3. So cos theta here is 1 by root 3. Yeah. So you got this. No problem. It's a silly mistake kind of thing that can be happen. Okay. Try to avoid it. Now cos theta is 1 by root 3, which means theta here is cos inverse 1 upon. Got it? So this is the answer. Very good, Jhansi. You have attempted this question and correctfully you have attempted. Thank you so much. And uh, yeah, it helps us to build your concept. Now, again, find the angle between force F 5I cap plus 4J cap plus 5K cap. These are the unit vectors. and displacement is 3 I cap, 4 j cap, 3 k cap unit. Also find the projection of F on D. ठीक है? Now try to solve this. At least this part, angle between force and displacement. Solution. Now here the force vector is given as 5 I cap plus 4 j cap plus 5 k cap. Okay. And displacement vector is given as 3 I cap plus 4 j cap minus 3 k cap. Okay. So we know that work done is nothing but we have to find the angle between force and dot. So what we can do, we can just take the dot product of them. F dot D is equals to magnitude of F, magnitude of displacement vector into cos theta. For angle, we have to say that cos theta is the dot product of F vector dot D vector divided by magnitude of F, magnitude of displacement vector. Now, how to calculate the magnitude? Look, if a vector, if a vector A is given to you as AX I cap, AY j cap plus AZ k cap, then magnitude of vector A is given by square root of AX square plus AY square plus AZ square. Okay. So based on that formula, try to calculate the magnitude of F. So magnitude of F is square root of 5 square plus 4 square plus 5 square. It is 25 plus 25, 50 plus 16, which is 66. Square root of 66 Newton. Now magnitude of displacement vector is 3 square plus 4 square plus minus 3 square. This minus play no role because it comes under the square, so it will become positive. So we have 9 plus 16 plus 9. 16 plus 9 is 25. 25 plus 9 is 25 plus 9, 34. Okay, got it? Correct, na? 25 plus 9. So displacement here, the magnitude of displacement is this. Now we have both the magnitude, only the dot product is remaining. So we can say that it is 5, put the value 5 I cap plus 4 j cap plus 5 k cap dot product with 3 I cap plus 4 j cap minus 3 k cap divided by magnitude of force vector, which is root 66, magnitude of displacement vector, which is root 34. So we will multiply them. ठीक है? 5 I cap multiply with 3 I cap. Firstly, we will take this term and multiply with all the three terms on the second expression. So 5 I cap multiply with 3 I cap. So 5 3 is 15. I cap dot I cap with 1. I have told you. Plus, you will, the shortcut trick is you will just have to take the product of I cap dot I cap, J cap dot J cap, and K cap dot K cap because all the other product will result in 0. So if you multiply this 5 I cap with 4 J cap, okay, Jhansi, very good. Let me check with the answer. So if you multiply this 5 I cap with 4 J cap, it will become 5 4 is 20 I cap dot J cap, which is 0. I cap dot k cap ultimately will become 0. So we will only take care about this 5 I cap dot 3 I cap, 4j with 4j and 5k with minus 3k. So 4j dot 4j is 4 4 just 16 into 1 which is 16 and 5 3 is 15 which means minus 15 is here. So we have root 66 multiply with root 34. Okay. Now this 15 and 15 got cancelled out. So cos theta you will have as 16 by square root of 66 multiply by the square root of 34. So this is the answer. Okay. So Jhansi, you are having 16 as a value of cos theta. You can also verify it like because cos theta, so what value you will have? Have you find the projection of f on D? I think you have find the projection of f on D. You know? But if you have find it out, okay, dot product. Dot product is 16. Good. Dot product is 16. So this is the angle. Got it? Now, if we calculate the projection, if we calculate the projection of f on D, I have already told you about it. How to calculate the projection. Projection is nothing but the component that I have calculated on another vector. Okay. So here you are with the projection. So if this is vector A, this is vector B. So if you resolve this vector A on vector B, which means in the direction of vector B, so this length, let's say A1 is the projection of A on B, which means if you let me tell you here, this is vector B, this is vector A, and if you put the torch on it, the shadow will create only on this part. So that is why it is termed as the projection. Okay. Now, how to calculate this? So with the help of dot product, A vector dot B vector is equals to AB cos of theta. And let's say we have to calculate the projection of A. So we will consider it at A cos theta to B. Okay. Which means A cos theta we have to calculate, which is the projection of A on B. So take B on the LHS. So it will become A vector dot B vector divided by vector B. Which means you have to take the dot product of both the vector and divide it with that vector on which the projection has been asked. Okay. So in this question, the projection of f on D has been asked, which means you have to project vector f on vector D. So you will have to take care of that. You will see that projection of f on D is equals to, it is not and, it is f on D. It is nothing but dot product of both the vectors divided by magnitude of that vector on which the vector has been projected. And this vector f is projected on vector D. So you have to take the magnitude of vector D. Dot product we have already calculated, which is 16 divided by the magnitude of vector D is nothing but square root of 34. So it is square root of 34. So this is the answer. I hope you are clear with this. If you have any kind of doubt, you can ask. Okay. Clear, Jhansi? I think you are clear with this question, huh? Just let me know if you are having any kind of doubt in that. Okay, good. Now, in this question, work done has been asked. And this is also has been asked in JE. Okay. So a force of F F vector is equals to, sorry, 5 I cap plus 3 J cap plus 2 K cap Newton is applied over a particle which displaces it from its original to from its origin to the point R vector is equals to 2 I cap minus J cap. So the work done on the particle in joule is. So we have to calculate the work done. Okay. Since this particle is projected from origin, so you do not have to worry about the initial position in calculating the displacement, which means this expression directly deal with displacement. It is given you as displacement. Okay. So Jhansi has answered is at +7. Let's see if she is correct or not. So work done is given by dot product of both the vectors. Now force F is given as 5 I cap plus 3 J cap plus 2 K cap dot product with D 2 I cap minus J cap. As I have already told you, you just have to take care about the same unit vectors, which means I cap, J cap, and J cap. There is no K cap vector. So in the final term, there is no K cap vector. Okay. So 5 I cap dot 2 I cap, which becomes 5 to the 10, multiply with 1 plus 3 J cap minus J cap, which is minus 3. 10 minus 3 is 7 joule. Okay. So plus 7 joule is the answer. So Jhansi, you are absolutely correct. Okay. Keep it up. You're doing so great. Good thing. Okay. Now, this this is a variation of question. Huh? This types of question is also has been asked. Okay. So I have varied the concept. Rather than solving same type of question, we will try different type of question to this. Okay. So this is a different type. Now in this question, try to solve this. In this question, the distance moved by a body of mass 0.5 kg under the action of a force varies with time t as x is equals to 3t square plus 4t plus 5. Now, what is the work done by the force in first 2 seconds? Now, here the force is not variable. Force is constant. Only the distance is varying according to this relation. Okay? Then, what we are going to do here? Any idea? So, you guys also solve it. I am also solving it for you. Okay? Then we will match your answers. Now, in this question, this expression is given as, yeah, we have to find the acceleration. To proceed in this type of question, we are having a blank value of force. We do not know what kind of force is acting. Na? So firstly, we will try to find out the force, value of force. And value of force is given by, according to Newton's laws of motion, it is F is equals to ma. So acceleration we have to find out. So for that, x is equals to 3t square plus 4t plus 5. We would have to differentiate this x with respect to time, so that dx by dt here is 3t square. Differentiation of t square is 2t. It is 60 plus 4, because differentiation of t is 1 and differentiation of 5 is 0. Okay. So dx by dt is equals to 60 plus 4, which is the Nothing but velocity. If you again differentiate it, which is d2x by dt square is equals to 6 plus 0, and which is dv by dt, which means change of velocity with respect to time, and it is nothing but acceleration. Yeah, very super fast, Jhansi Rani. You are behaving like your name, Jhansi Ki Rani, na? Good. So let me check the answer, okay? So acceleration here you have calculated as 6 meter per second square. Now the value of force is mass into acceleration. That is why the mass in this question has been mentioned. So mass is 0.5 multiplied by 6. It is 3 Newton, which is a constant force. Now you can directly calculate the work done. So what is the work done? Work done is nothing but force multiplied with displacement. Or here the displacement is mentioned in x, so we will take it x. Okay. So magnitude of it will be, because this is a constant force, 3 multiplied by, it is not x, it is delta x, the change in position. So it has been asked that what is the work done by the force in first 2 seconds, which means t is equals to 0 to t is equals to 2. Now we will have to calculate the value of x at 0. So it will be 0 plus 0, put t is equals to 0. 0 plus 0 is equals to 5, which is 5 meter. At t is equals to 2, it is x is equals to 2 is 3 into 2 square. Put t is equals to 2 plus 4 into 2 plus 5, which means 2 square 4, 12 plus 8 plus 5. It is 25 meter. Now the work done is F into delta x, which means force 3 Newton has displaced this from 5 meter to 25 meter. So x, delta x is nothing but x minus x initial. So final you will have 25, initial you have 5. So you have 60 joule. Okay. Let me tell you one thing, Jhansi. I'm not saying that you are doing anything wrong. It is very good to solve the question if you has been asked to solve the question. But try to avoid these silly mistakes. Okay? Because if you are in sitting in a, if you will sitting in a exam hall and you just write it as 75 joule, then what will happen? Your concept is true, but the silly mistakes that you have made, you just, I think you have put 25 directly and then multiply it with force, na? 25 3 is 75. Okay. So try to avoid these mistakes. Okay. Because if you are able to understand a quote which is said to be in Hindi, it is धीरज काम बनाए जल्दबाजी काम नसाए. Means if you are in a hurry, then your work will be demolished. ठीक है. तो उसमें कुछ ना कुछ रुकावटें आ ही जाएंगी. ठीक है. You have to be patient while you are doing work. Okay. Now move on to the next question. Here it is on your screen. So a uniform chain, it is a heavy question. A uniform chain of length 2 meter is kept on a table such that a length of 60 centimeter hangs freely from the edge of the table. The total mass of the chain is 4 kg. Then what is the work done in pulling the entire chain on the table? Okay. Let me tell you one concept in this types of situation. Look, this is the chain which is partially on the table and partially on the, it is hanging. So what you will do in this types of situation, the hanging part you will consider as a block of mass exactly equals to the mass of the lower portion which is hanging. Okay. So you can replace this situation as a mass tied on it. And this length is nothing but from this point, from where the hanging has been started, from that point to the center of mass of this. So this will be at center of mass. So you will consider the hanging part, hanging chain as a block and exactly at a distance where the center of mass of the hanging part lies. ठीक है? Now, कॉन्सेप्ट तो समझ लिया. अब इसकी एप्लीकेशन देखते हैं. We will apply this. Okay. Now we are going to solve it. So this is the table you have on which this chain is placed. Okay. The length, entire length is 2 meter and the hanging length is 60 centimeter. 2 meter means 200 meter, which means 140 meter you have on the upper side. 140 centimeter. Look, now if I ask you what is the weight of the hanging portion, so you will calculate is that like 200 centimeter has a weight of 4 kg because the entire chain has a mass of 4 kg, which means this 4 kg mass is distributed to 200 centimeter. Okay. Now for 1 centimeter, it is 4 by 200 and we have to calculate it for 60 centimeter. So 60 centimeter, it is nothing but 4 by 200 multiply with 60. 4 5 ja 20 and 6 divided by 5 is 1.2 kg, which means mass of this part will be 1.2 kg, which is hanging. Okay. If I talk you about the center of mass of this hanging part, so it is exactly at the mid part because it is a uniform chain. So it is exactly at the mid portion, which is at x center of mass is equals to, or you will see that center of mass of hanging part will lie on half of this, which means half of 60 centimeter is 30 centimeter. So now you can consider it that this is a block of mass 1.2 kg, which is placed at a distance of 30 centimeter. Now the question is simple. You have to pull the entire chain on the table, which means you have to pull this block to the table, which means you have to cover at least a distance of 30 centimeter. Got it? Now, what is the force that you have to apply? So you must have to apply a force which is greater than the mass hanging downward direction. You have to take care of that mass, na? You have to pull that block. So at least you have to apply the same force which is this mass is exerting. Okay. And you will see that this block mass M is pulled by the gravitational force which is mg. So you have to apply a force which is exactly equals to mg so that you can pull it. Although this force is slightly greater than this mg, but we will consider the limiting value. So this force that you have been applied, it is the external force. External force is exactly equals to the weight of the block. Now, work done here is force multiply with the displacement, because here the force and displacement, this is the applied force, and in this direction you are the block is going up and the force is also going up. Okay, force is also acting in the upward direction that you have applied and the block is also moving up. So the angle between force and displacement is 0. So that is why I have directly written it. Otherwise, you can write it as force vector dot displacement vector cos 0. cos 0 is 1. So it is F dot, means multiply of magnitude of force, magnitude of displacement. So force is here is nothing but 1.2 mass into gravity, 1.2 into 10, which is 12 Newton into 10, multiply displacement. Here is you have to take displacement in meters, because for Newton, having the unit as Newton, you have to take the displacement. You have to take the displacement in meter. So how much displacement this block has been needed? It is 30 centimeter. 30 centimeter means 0.3 meter. Got it? Because 100 centimeter में 1 meter. So now calculate it. It is 12 multiplied by 0.3, which is 3.6 joule. So I hope you are clear with this. Okay. If you have any kind of doubt in this question, I will re-explain it. Okay. Got it? Okay. If you are clear with this, then write yes in the chat box. Okay. Why we should take 30 centimeter? Yeah. Because the concept here is, if you will see, so the concept here is, Jhansi has been asked this question. Na? The concept here is, if you are able to pull this, if any force would able to pull this chain up to its center of mass, now the center of mass is upside. So only the lower portion is downward, which means this portion is not able to pull the chain downside. Okay, that is why at least 30 centimeter, at least the center of mass of that hanging portion, we have to pull. Got it? Because in Newton laws of motion and in physics, the uniform mass body, you can take it as the point mass. Okay, the concept of point mass is there in Newton laws of gravitation also, and in Newton laws of motion. F is equals to ma is only applicable for the point masses. That is why this hanging chain I have to consider a point mass, and this point mass lies exactly at the center of mass. So that is why I have assumed this as a block which is at a distance 30 centimeter. Okay. Okay. So this is it from my side. I hope you are clear with this. Thank you so much, guys, for attending the session. Okay.